Okay, tonight I'm just finishing off this Technics Su 3500 I bought a couple of months ago. This is going to be one of my keeper amplifiers. I love these amps, I think they're great. I had one 25 years ago, and it's such a nice sounding amplifier. They're quite a warm sounding amplifier, but they're beautifully made, and as you can see, this one's in really nice condition, so I'm going to keep it. What I'm doing now is I'm going to set the various offsets and biases on the output stage. It has some adjustments here to adjust the voltage to the preamplifier. This is basically a crude linear regulator, really. That's been set. I think that's a plus or minus 40 volt adjustment, which is this point here. What I'm going to do now is do the DC unbalance adjustment, and that's achieved by test point 13 and 15. Now these are the test points on the board here, and basically, they're actually marked, which is useful. I didn't notice they were marked. So you put a DVM across those 2 points, and basically what this is doing is looking at the output of the amplifier, and we're trying to get the DC offset as low as possible, which is most of the modern amplifiers have a sort of like an automatic servo circuit that will keep the voltage down as low as possible anyway. But what this amplifier does is it has a preset adjuster to adjust that level. So we do DC unbalance between test points 13 and 15, and we adjust VR 401 and 402, 401 of the left hand channel. And there's VR 401, and as you can see there, it's marked DC. A present offset is 5 millivolts, which is perfectly good enough, really. But let's just see if we can get that in a bit more. So this is our potentiometer. Just watch the offset on the adjuvant. It's the wrong way. As always, a very touchy control, probably quite dirty pot as well. Okay, so what I'm going to do, the pot is dirty. You see it's jumping all over the room. I'm hardly moving the pot at all, so what I'm going to do is turn the amplifier off briefly, give it a quick squirt of contact cleaner, work it, put it back to where it was, and repower up again. Give the amp a few seconds just to sort out its DC offsets and things. Okay. And we'll have another go. I mean, 7 millivolts is perfectly okay. I wouldn't normally bother as I'm doing a video demonstration. So there we go. Get it as low as possible. If you go too far, you'll start to go negative, as you see there. Okay, minus. It's not that sort of hypercritical, to be honest with you. As long as you've got the offset down below about 10 millivolts, that's perfectly adequate. And it's going to drift around all over the place. It depends on the mains voltage and things like that. But there you go. That's 500 microvolts is pretty good. Let's move over to the next channel. That's at 9. I'm going to do the same with that one. Give it a squirt of contact cleaner. Work it a few times. Clean the track. Wait for the amplifier to stabilise. 10 seconds or so to stabilise. Okay. Let's get that as low as possible. Yeah, it's a bit jumping around all over the place, this one. Okay, this pot seems to be very noisy. Well, I've got a bad connection, so let's double check the connection. Let's work the pot. wind it backwards and forwards, it just cleans the wiper across the carbon track. Let it settle again. Okay, I'm getting much better adjustment. There we go. So yeah, it's always worth doing that, especially on these old carbon resistors that are exposed, particularly these sort of skeleton type resistors. They're all exposed to the elements and all the atmosphere, and God knows what. If the owner's smoked, it's probably got a layer of nicotine across the track as well. Okay, so that's that. So the next point to do is do the quiescent current. And the quiescent current is 15 millivolts in this amplifier, and that's across test point 14 and 13. So they're the two upper connections. So connect across the two upper connections. We've got 10 millivolts. Okay, now what I tend to do, and you don't have to do this yourself, but I tend to increase the bias currents. Probably I'm going to take it to 20 millivolts. I always believe that these amplifiers sound slightly nicer once they've warmed up, and if the amplifier is running a little bit warm, that will always help. I'll turn the amplifier off and clean the track like I did on the last one. Just run the pot backwards and forwards to scrape off any muck on the pot. Repower up again and wait for the amplifier to stabilise. So what I'm basically doing is taking this amplifier out of a Class B operation and pushing it more to Class A. In other words, I'm applying base drive to the transistors just to turn them on. So the audio signal, if a low audio signal, the transistor is already turned on, and you won't have a slight delay as the audio signal turns the transistor on, and that results in crossover distortion. Okay, so it's suggesting 15 millivolts. I think we'll go for 30, and we'll see how we get on with that. So let's get to 30. I mean, I've hardly turned it at all actually. If you look at the pot when I've finished, ignore the negative reading. As long as you've got 30 millivolts potential difference across the 2 points, that's fine. So 30 millivolts. You can see the pot's hardly been turned at all. Let's go to the other amplifier. You shouldn't go too far with these, especially on the older amplifiers. If they haven't got a good thermal compensation, you can run into problems like overheating, thermal runaways, that sort of thing. So let's have a look at this one. That's 14. Let's try this pot without cleaning it, see if we can get anywhere. So back to that one at 30. Yeah. Well, we look like we're okay actually on that pot. So there you go, 30 millivolts. So that's the amplifier's currents all set up. So we've got no DC offset on the speakers. We've got the transistors biased to slightly over biased. It's not going to be a problem. So this amplifier is, in good condition. So yeah. Thanks for watching, and it's basically the same with all Class A B amplifiers. You need to run through certainly the quiescent current adjustment, but as I say, with the DC offset control, it tends to be that only the earlier amplifiers had that, and not all of them do even that. I mean, even amplifiers of this era, most of them are sort of like servo controlled. For some reason, Technics decided to use this preset adjustment. Works perfectly okay, but it's not the norm. Let's say that. Anyway, thanks for watching.